Myself, Dr. K. Viswanath Allamraju, Department of Mechanical Engineering, Institute of Aeronautical Engineering, Dundigal, Hyderabad. In this session, we are going to study the resultant of force. Here, as we have studied, there are various laws in engine mechanics. One of the law is Parallelogram Law of Forces. The Parallelogram Law of Forces indicates that here the P and Q are acting at a point. These are the two forces acting on a particle A. The particle A, that particle A, the effect of the forces P and Q on particle A is equal to the effect of a single force R. This R is known as the resultant of the forces P and Q. Resultant force, resultant of the forces P and Q, capital P and capital Q. Now here, how to find out this resultant force? The methodology, the law which we are using to find out the resultant forces of P and Q is known as the Parallelogram Law of Forces, for the addition of two forces. How to draw this graphically? There are P and Q are known vectors. Draw a line parallel to P and draw a line parallel to vector Q. It intersects at another point. Now join the diagonal of this parallelogram that represents the R. The diagonal of this parallelogram is in blue color, that is R. The measurement of this diagonal is known as the resultant of the forces P and Q. Thus, we have to find out the resultant of the forces of P and Q. So here, we have to use this, how to find out the resultant force by using the graphical method. That graphical method, by using which law? That is the parallelogram law. Why it is the parallelogram law of forces? Because the resultant force, the diagonal of the parallelogram, is known as the resultant force of P and Q. Alright, here, now, let me read here. The resultant force can be obtained. How? By using adjacent sides, by drawing the adjacent sides or parallel lines of P and Q. By joining the diagonal represents and passing through A is known as the resultant force. The method of finding out the resultant is known as the parallelogram law for the addition of how many forces? Two forces. So what is the limitation of this parallelogram law? The limited condition of this parallelogram law is that it is only applicable. We can find out the resultant force only for when two forces are acting on a particle. More than two forces, it can't be applicable. If more than two forces are acting, then which law is applicable? We have to find out the resultant force. That law is known as the Polygon Rule. That is another law of mechanics. So here, on particle A, there are several forces are acting. That is the P, Q, and S is acting on that. This P, Q, and S are acting on the point A in different directions with different magnitudes. Alright, so how to find out the resultant force? What is the resultant means? The effect of all these three forces replaced by a single force. That single force is known as the resultant of these forces P, Q, and S. So how to draw this? By using the graphical method, we have to consider the length of the vector. The magnitude of the vector Q is to be converted into the required scale and draw a line with the same angle of direction. The angle here, it is theta 1, and what about here? It is theta 2, and here it is theta 3. So draw the vector line, that is the P, and join the P with the Q, the same direction. the q vector is parallel to the q which is mentioned here. And one more thing, that the p, the direction of the p is same as the direction here, the same magnitude and direction. And s, it is also same as s. The closing side, after joining this, there is a closing. That closing side joining the particle A with the closing side of the S, the starting of the S, that gives the represents the resultant force. Resultant. So the rule which we use to find out the resultant of the forces which are acting more than the two forces, that rule is known as the Polygon Rule. Okay. So the Polygon Rule, the limitation of our Polygon Rule is, if two forces are acting, it can't be applicable. If more than two forces are acting, the Polygon Rule is applicable. So for two forces which are acting on a particle, to find out the resultant force of those two forces, we have to use the simple method is the parallelogram law. And the more than two forces are acting on a particle, the method of finding out the resultant force, graphical method, is by using the Polygon Rule. Or okay, so we have learned now two laws. One is parallelogram law and the second one is the Polygon law, Polygon Rule. So here what is one more thing, this single force is known as the resultant of all the forces. But what is the order we have to follow? We have to follow which order? We have here in this case we began with the P, Q and S. So the order we can follow, the order of following of the forces is immaterial. We can follow any order. You can take first S, and S is joined with the Q, and S is joined with, and Q is joined with the P. So any arbitrary, no problem. But the final point, the final principle is that the closing side of the end of any vector to the starting of the vector, that is the particle A, that it gives resultant R, that resultant force R. Now a single vector, now very important is that the single vector V is acting on a particle with some inclination. So how to be the single vector, the single force V acting on a particle? If we want to replace the single vector with the two forces, two components, those two components have the same effect on the particle, which is equal to the effect of the vector V. Here the vector V is resolved into two components, one is Vx and Vy. The Vx and Vy acting the same effect equal to the vector V. Okay, so it is the reverse of the parallelogram law of forces. It is the reverse of the parallelogram law. There the Vx and Vy, the parallelogram we have drawn, and the diagonal joined, the diagonal represents what? Represent the resultant of the forces there in P and Q. But similarly, now suppose the force is acting with some inclination. So to find out how to divide the resultant force into two components. The two components, that is Vx and Vy, one is horizontal component, another one is vertical component. So these forces are called the components. These forces are called the components of the original force V. And the process of substituting them for V is called the resolving the force into components. That is called resolving the force. Resolving the force. Now, most convenient here to deal with the vector components which are mutually perpendicular to each other. These are called the rectangular components. Okay, rectangular components. Now, how to divide? We are going to study the rectangular components more and of different when number of forces are acting and finding out the resultant force. Okay, how to find out the resultant force of this rectangular component here. Now we are going to study the rectangular components. As we have studied we have studied here resolving the force into components. We are going to resolve the different forces into rectangular components. These are known as the resolving, that means rectangular components of the forces. Now here, rectangular components, how to make it, divide this into rectangular components, find out the resultant of the coplanar concurrent forces system. Is the body, and the body it is being acted by the force F1 with the inclination is theta 1, force F2 with the inclination of theta 2, force F3 theta 3, force F4 theta 4. So how to find out the resultant force? There are two methods. One is the graphical method by using the Polygon law, and another one is the analytical method. We are going to study the analytical method. Analytical method. How to find out the resultant force by using analytical method? That's what resultant force are. First, we have to divide all these forces F1, F2, F3 and F4 into rectangular components. The method is that draw a perpendicular vertical line and a horizontal line. This horizontal line is parallel to x-axis, vertical line is parallel to axis y. Now, the angle is making here theta 1. That means it is F1 cos theta 1. And here it is F1 cos F1 sin theta 1. It is F1 sin theta 1. Similarly, horizontal component in this direction, vertical component. This component is F2 sin theta 2. It becomes F2 cos theta 2. The next, divide this horizontal and vertical. The angle made here, it is theta 3. It becomes F3 cos theta 3. And here it is F3 sin theta 3. Now divide horizontal and vertical. The direction it is made here theta 4. This component becomes F4 sin theta 4. And it becomes F4 cos theta 4. Okay. Now make it all x components. Sigma fx equal to sigma fx, all horizontal components. What is the sign convention? It is the plus positive direction towards the right side, and negative x-axis is the towards left side direction. Now upward components are positive, downward force components are negative. This is the sign convention we are going to follow. Sigma fx equal to the component 1 here, F1 cos theta 1 is going towards right, it is the positive. Next, minus F2 cos theta 2 towards left, negative. Coming to F3, that is F3 cos theta 3, it is positive towards right direction, right side direction, right side. And what about F4? It is negative. F4 cos theta 4. It is left side. These are all x components in horizontal parallel to axis x. Next is sigma Fy in vertical direction. The upward direction of the y is to be considered as positive and downward direction y is considered here we assumed as negative. That means F1 sin theta 1 is positive plus F2 sin theta 2 is also positive minus F3 sin theta 3 is negative, is downward, negative y, and F4 sin theta 4 is downward direction, also negative. The value of sigma fx, in that sigma fx terms, there are positive terms and negative terms are there. Similarly, in y terms, sigma fy also positive, negative terms are there. This sum is known as the algebraic sum. Algebraic sum means Algebraic sum means the sum consists of the both positive and negative terms. Alright. Now what is the resultant force? Now the resultant force, this is sigma fx and it is sigma fy. We don't know what is the direction completely. If the positive comes, we have to consider, but we are assuming sigma fy. The resultant force, or you can consider the upward or it here also downwards. Okay. The resultant force R equal to, what is the R equal to? The diagonal. That R equal to under square root of sigma fx square plus sigma fy whole square. This is the resultant force. What about the direction of this resultant force? The direction of the resultant force theta equal to tan inverse of sigma fy by sigma fx. This is theta gives the direction and r gives the resultant. This is the theta. This method is known as the analytical method of calculating the resultant force of a coplanar concurrent system. Okay, coplanar concurrent forces system. Now here, how many components are there? How many forces are acting on a particle or on a body? There are 4 forces are acting. All forces are going away from the particle or tensile nature. Now, that is sigma fx, sigma fy. We have calculated this sigma fx and sigma fy is the sigma fx is the algebraic sum of the force in x direction. Sigma fy is the algebraic sum of the forces in y direction. These two are forces. The total all forces are being divided. Okay. In x and y direction, then these are the two forces. The sigma fx represents the horizontal components of all the forces F1, F2, F3 and F4. Sigma fy represents all the forces effect F1, F2, F3 in the vertical direction. So this fx and fy are being replaced by the single force. That force is known as the resultant force. This resultant force gives, now you see the so mystic. Here F1, F3, F4, all the forces are acting. These all forces are having with some inclinations. All these forces are represented by a single force. That single force is known as the resultant force. That resultant force is being calculated here by using the method. That method is known as the analytical method. But we used what? Resolving all forces into rectangular component, horizontal and vertical. Now what is another method? The another method is by using graphical method. That graphical method is by using Polygon Law of Forces. The Polygon Law of Forces, as we have discussed, by using here. Now, if we consider the particle A in F4, consider it. It's okay. F4, that is a PQR, or small, or you can RST, we can consider it. So you follow this method by considering whatever forces we consider here, F1, F2, F3, and F4. We know the inclinations theta 1, theta 2, theta 3, and theta 4. With these inclinations, you order is random. Anything you can order of the forces are immaterial here. So consider the F1 with the angle of theta 1. Then what to do? Again theta 2. This is F2. Next, go for theta 3. This is F3. With the horizontal, yes, it may not be force. And go for next theta 4. And the force is F4. The joining of the starting point to ending point, this represents the resultant force. What is the angle? This is the angle, resultant angle. This is the R, is the resultant force. That R is same as the R which we calculated by using analytical method. But in graphical method, analytical method is more accurate than graphical method. Alright. So here there will be small percentage of error may be occurred. Because the graphical method we considered here, we are considering length, which is 1 millimeter also affects the resultant force. Now this is the graphical method by using which law? Polygon Rule or Polygon Law of Forces. Why we use here Polygon Law of Forces? Because the more than two forces are acting. Alright, thus we have to use graphical method and also analytical method. Now this here, in this we consider the case study. All the forces are acting away from the particle in tensile nature, in pulling in nature. F1 is pulling with theta 1 direction, F2 is pulling in theta 2, F3 is pulling in theta 3 and theta 4 and so on. Okay, now here point is that suppose some of the forces are in compressive in nature going towards the point. Some of the forces are mixed going away from that. We have to consider that case study now. What is that case study here? There is a body which is acting F1 in upward direction theta 1 and F2 in downward direction having inclination of theta 2 and F3 also towards the body particle, that is theta 3, and F4, yeah, you can consider towards the body F4, and it is making with this inclination theta 4. So how to do it? How to resolve these components into horizontal and vertical? Resolution or resolving the components. How to find out the resultant force? By using or by resolving the components, or by using analytical method. By using analytical method, yes, draw a lines parallel to y-axis and parallel to x-axis. Now this component parallel to x, the angle made with the horizontal is theta 1. This becomes F1 cos theta 1. This is F1 sin theta 1. You go for any method here, yes, horizontal and vertical. This is a horizontal component. and here it is vertical component. Please observe here. This is the here it is downwards. If you make it vertical, the direction is downwards. If you make it horizontal, the direction is moving in this direction. So it is going towards right direction. Then this component, this theta 2, then becomes what? F2 cos theta 2, and it becomes F2 sin theta 2. Next, make it horizontal and vertical. Now it is towards downwards, here horizontal, and it becomes vertical. It's theta 3, that is F3 cos theta 3, and it becomes F3 sin theta 3. Next, draw a horizontal line and vertical line. The angle made here, it is theta 4. So what is the direction? This is the direction vertical and it is the direction horizontal. Then here F4, it becomes cos theta 4, this component. And here it is F4 sin theta 4. Okay. Now we have to resolve this. Now apply here algebraic sum of all horizontal components, sigma fx equal to what are the horizontal components are? The horizontal components are f1 cos theta 1 is moving towards which direction? Right side. It is the positive. If it moves towards left, it is negative. The next horizontal component is f2 cos theta 2. That is the positive f2 cos theta 2. The next f3 cos theta 3. And final one, f4 sin theta 4 is moving towards left, minus f4 sin theta 4. Now here the sin theta term become a horizontal. Why? It is making the angle f4 is making with the vertical axis theta 4. The next is sigma fy. What is sigma fy? Again terms, f1 sin theta 1 is positive, minus f2 sin theta 2 is negative downward direction, plus f3 sin theta 3 is upwards. What about fourth f4 component? The f4 component is plus positive f4 cos theta 4. The cos theta 4 is vertically upwards, is the positive. That's it, over. Sigma fx we know, sigma fy we know. If sigma fx comes, we'll discuss. There are different case studies here. Now, what is the resultant? R equal to under square root of sigma fx whole square plus sigma fy whole square. Okay, now what about theta? The theta equal to the direction tan inverse of sigma fy by sigma fx. This R is the magnitude of the resultant force of F1, F2, F3 and F4, and theta is the direction of the resultant force R. How can we know this theta R, which coordinate, in which direction it is acting? Suppose if sigma fx is positive values occurred, and sigma fy is also occurred in positive. Now 4 coordinates here, sigma fx is positive, sigma fy is positive. That is the first coordinate system. It is acting in first coordinate. And if fx is positive and fy also positive, then the resultant comes in this upward direction. If fx is negative, sigma fx is negative and sigma fy is positive, it is in second coordinate system, then resultant acts in upward direction. In this direction, the second coordinate. If sigma fx is positive, alright, sigma fx is positive and sigma fy is negative, then this is a coordinate. Then both are going away. This is a coordinate system. This is the third coordinate system. And sigma fx is negative and sigma fy also negative. Then it becomes, in fourth coordinate, here it is in third coordinate. Thus, we have to find out the location in which direction the resultant force is acting. So we are here, I consider Fx and Fy both are positive. The Fx and Fy both are positive, that's why the R I considered as a first coordinate. The R is acting. This is sigma Fx and it is sigma Fy. The resultant is the R. The angle made by theta, the resultant, that is the theta here. So in this manner, we have to find out the resultant forces of a coplanar concurrent force system by using the method that is analytical method. Okay. Now, in this session, let me summarize. In this session, what we have studied? We have studied what are the laws of mechanics. First law is the rectangular law or parallelogram law of forces. The second law is the polygon law of forces. And by using the polygon law, we found out the resultant force of the coplanar concurrent force system. And also we use analytical method to find out the resultant force of a coplanar concurrent force system. In coplanar concurrent force system, by using analytical method, we have studied here two cases. One is all forces are acting away from the body, away from the particle, that is in rectangular nature, in a tensile in nature. And also the direction of all forces are we consider with respect to the horizontal x-axis. And we have studied or we found out resultant force by using analytical method for the case of forces are acting. Some of the forces are, there are three forces are acting in compressive in nature towards the particle, and one of the force is acting away from the particle. And the angle made by force F4 in this, here it is the angle making with the axis, vertical axis. So by considering the nature of those forces, we found the resultant force and also find out not only magnitude but also direction and also point of application. So with this, we can end this session. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.